Hi there, this is Penelope. This is a short video of the Speech Marks live session of Topic 2, Class 2. And the reference, if you've got the textbook, is Chapter 6 of Croft and Davison. We're looking at functions. In particular, we're looking at finding the inverse of a function. Just need to note here that x can't be 0. Now, if we do this correctly, we will find that the inverse on the original will equal x. So that will prove that we are right. So we can start off by saying, well, let y equal f of x. So that equals 3x minus 2 over x. Now, y equals 3x minus 2 over x, which means if we rearrange things, we can find that. Now, if that was a bit fast, let's do the working. So we've got y equals 3x minus 2 over x, cross multiplying, shifting the 3x, factorising the left-hand side, and then dividing both sides by y minus 3. So that gets what we had before. Now this is equal to f inverse of y, but we don't want that. We want f inverse of x, which is negative 2. Replace the y by x, and we've got that. Now, if we are correct, then as above, if we apply the inverse to the original, we'll be done. So the inverse performed on 3x minus 2 over x. So we're saying that it's negative 2 over x minus 3. So now I have to put 3x minus 2 over x instead of x. And if you play around with the fractions there, you end up with negative 2 times x over negative 2, which indeed is equal to x. Big red tick, because we got that right. So we have found the inverse. The inverse then is that function there. And remember, it's nothing to do with powers, it's simply to do with notation about how we actually write the inverse. Sketching a function parametrically or writing a function parametrically, that's where we use a third variable. If we've got, say, x and y, we use a third variable to express it. One of the ways you can do it is to draw yourself a table. Now it tells us that t is greater than or equal to 0, so let's just arbitrarily choose some values. And now we just go through and, according to the rules, fill in the numbers. And 1, 2, 3, 4, 5. Okay, now what that does tell us is that x is less than or equal to 0. We could be asked to write that algebraically, so let's have a look. So we've got x equals negative root t, y equals t. That's what we had. Now, using the left hand side, multiplying both sides by negative 1 and squaring both sides, and just tidying that up a bit. But we know that y equals t. So now we can say that y is also equal to x squared. Now, if you were to draw that, you know that it's a parabola, but provided here, in this particular case, x is less than or equal to 0. And there it is there, which is what you'd expect it to look like. Next we need to have a bit of a discussion on periodic functions. Basically, if a function is periodic, it's saying that it repeats. And if it repeats, if the period is t, then what we've got is that x plus t in the function gives us back where we started, just f of x for all values of x. So t is the time interval between two successive repetitions, and it's called the period. Now if we look at, say, y equals sine x, that's periodic in x with period 2 pi, because sine x is equal to sine of x plus 2 pi, which is equal to sine of x plus 4 pi, etc. And similarly for cosine. Now we can talk about an odd function, and I don't just mean a peculiar one, I mean an odd function. We say a function is odd if f of the negative of x is equal to the opposite of f of x, and we talk about an even function if f on the negative x is just f of x. So an example of an odd function would be x cubed, maybe sine x, and an even function would be x squared and maybe y equals cos x. Sometimes we're asked to draw some really crazy looking functions. Now this one we need to mark off 2, (3 pi by 2), 2 pi, and maybe negative pi by 2 just for fun. Now what it's saying is that the function is at value 2, so y is 2 between 0 and pi by 2, and then between pi by 2 and 3 pi by 2 it's actually negative 2, and then between 3 pi by 2 and 2 pi it's 2 again, and it says it's periodic with a period of 2 pi, which fits what we've drawn, because from here to there is 2 pi, and if we were to draw it again, I mean if we went backwards a little bit, then this is what it would be doing there. So you can see it's about to start again, so it's been through one whole iteration. The next one, again, it's got some pi's in it, and we need pi and 2 pi and negative pi, and the same here, and maybe negative 2 pi. From negative pi to pi, it's like that. Now with a period of 2 pi, it's going to start again, so it's not very accurate, but so it's going to start, whoops, gone too far. It's going to start again, and similarly on the other side. And that fits with everything that is explained in the question. It's got a period of 2 pi from, say, here to there. That's 2 pi, and it fits the f of x equals x in that space. The last question I want to go over is a really interesting one. Later on in the course, when you look at this, you see, oh, well, I can do this. I need calculus, but we haven't done calculus yet. So this is something we need to do without any calculus. First thing to recognize is that the function that we're given is a circle, and the center of the circle is AB. And in this case, AB are, well, A is the x term over 2, and B is the opposite of the y term over 2. Those are just rules. So the centre is at 0, 2. Okay, so the centre's at 0, 2. Now, the point on the circle, I'm just going to do that. So there's our centre, and we've got our point somewhere out here. So this is 0, 2, and this is 2, 1. We can find the slope of that line. So the slope of the line joining those 2 points we can find that. It would be, what would it be? It would be 2 minus 1 over 0 minus 2. So it would be negative 1 over 2. My diagram's not really quite right, but that's the slope from the centre to the point, and let's call that n. Now, the slope of the tangent will be perpendicular to that. In other words, m times n will be equal to negative 1, which means that m must be 2. Okay, now we know enough to find the tangent. So the tangent has a slope of 2 and passes through 2, 1. All right, so we can use any variant of how to find that. We could use y minus y1 equals m times x minus x1, or we could just use y equals mx plus c, doesn't matter. If we use the bottom one, then 1 is equal to 2 times 2 plus c. So running out of space there. So c equals negative 3. Therefore, our equation of the tangent will be mx plus c, where m is 2, x minus 3. Okay, which kind of is a bit better on my diagram. Here's the pretty version of that. So the circle has a centre at 0, 2. So what we did was we found the slope of that line, and because we just chose that to be the radius at that particular point, it is a right angle there, and so the slope of the line joining 0, 2 to 2, 1 is, so mn was equal to negative 1 because they're at right angles. And then we could find m and then use it to find the equation of a line that passes through the point given. Okay, thanks for watching.